Hi, and welcome back. So last time we talked about the idea of type coercion, that whenever you mix inside of an atomic vector different elements that have different classes, then we move in order from least complex to most complex. And the least complex is logical. Then we have integer information, then numeric or real numbers. So that's anything with decimal places, all the way up to character information. And so if you try to mix classes of information inside of an atomic vector, then whatever is the least complex is going to get promoted up this ladder to whatever is the most complex element in that atomic vector. And the reason this happens is because, again, the definition of an atomic vector is that all of the elements of this ordered set have to have the same class. And so if you provide elements that have multiple different classes, then R will promote to preserve the complexity of that information, to try not to destroy information, if you will. So I've got this again. I've got my like login vector or whatever with my information here, and now we're going to talk about attributes. So this is a special type of information about a, a vector. This is sort of like meta information, if you will. If we used the structure function to look at two different vectors, so there was one, we made a vector of animals that we had mouse, rat, and dog, and then we also had a vector of our ID. And if we use the structure function, the structure of animals is actually very simple. It says, oh, this is a character vector. It has length 3, so the elements are indexed by 1, 2, and 3. So you remember that this 1:3 says create a vector of integers for 1, 2, and 3. So the elements are indexed by 1, 2, and 3. And the elements are, the first three elements are mouse, rat, and dog. Okay. Now, if I look at the structure of my ID vector, this is a bit more complex. Number one, it says it says it's a named character vector. It has 8 elements, so this makes sense. We've got 1, 2, 3, 4, 5, 6, 7, 8. One for each of the elements here in this vector, and it gives me what the values are in this vector, but it also gives me, in like a bulleted list almost, this thing called ATTR for attribute. So there is an attribute to this character vector known as the names. So this vector has an attribute called names. Now, what does this mean? Basically, it is R's way of giving you a little bit of flexibility with atomic vectors so that not everything in that vector has to have the exact same class. Well, let me back up. Everything in the vector has to have the exact same class, but an attribute is kind of like if we had taped something to the side of the vector, if you will. So I've got my suitcase, and if I'm saying my suitcase is atomic, then everything inside of that suitcase is all, let's say, articles of clothing. Okay. So I've got my 10 shirts and my 10 pants and my 10 pairs of socks. But then I need to bring something else, but it's not an article of clothing, but I want to keep everything in the suitcase in article of clothing. So in the outside flap of the suitcase or something, I tape something onto the side of the suitcase. Maybe I tape some important, like some documents, or I tape my address. I use some masking tape and I put it on, like, okay, this is Gabriel's suitcase and this is where I live, something like that. I put a clear masking tape on the outside of the suitcase. Um, that would allow me to have information, if you will, that gets around the restriction that everything be the same class or the same type. So right here, I have that all of the elements of this vector are character information, but I also have a names attribute, which is itself another character vector. So you could think about this. These don't have to match. I could have one type of atomic information over here, and then I could have an attribute that has a different type of atomic information right here. Now, we've actually seen something like this before. So if I create a matrix called X, and I say, okay, this is a matrix of zeros with n row is equal to 2 and n call is equal to 3. Okay. And I create, so let's take a look at XMAP, this matrix. Okay, so I've got 2 rows and I've got 3 columns. Let's take a look at the structure of this. Well, let's add some, let's take a look at the structure of this. Oh, I needed to give it an object, structure of XMAT. And it says it's numeric. It tells me how to subset this thing. And it says that there are 2 rows and 3 columns, and then all of the elements of this matrix are zeros. Now I'm going to add a special type of attributes called the column names. I'm going to say the call names of XMAT are going to get, well, there's 3 columns here, so I need to give it 3 things. So how about X, Y, and Z. Now, if I look at the structure of this object, it says that I've got some attributes. In this case, there's an attribute called dim names. So anytime you work with a matrix, or I think it's matrix is going to have dimension names. Matrices or arrays have dimension names. And the first one, it says null. Remember that the numbers that come first for a 2-dimensional array or a matrix in R correspond to the rows. So the row names are missing, they're empty. But the column names is a character vector of length 3. So let's take a look at XMAT again. So now I have column names. Let's add some row names now. So row names of XMAT. And there are 2 rows, so I need 2 names. I'm going to call this sample 01 and sample 02. Now, when I look at the structure, let's take a look at the structure of XMAT. I now have attributes on the rows. The rows are called sample 1 and sample 2. The columns are called X, Y, and Z. And let's go ahead and print XMAP. And so I see row names. I've got sample 1 as the first row, sample 2 is the second row, and then I have columns X, Y, and Z. Okay, and these were attached to. Now this is an atomic piece of information. So what is the class of XMAP? And it should be numeric. Well, it's matrix. Oh, this actually goes back to class versus type of. So the class is matrix. The type of XMAT is double or numeric information. Okay. And it's coming through, and when I look at the structure, it says it's numeric. So it has a class of matrix. It has a storage mode of double, i.e. double precision information. That's the real numbers, if you will. If I wanted to, I could make this thing integer. If I go back to this, if I say XMAT, and I'm going to give me, I don't want to overwrite the row names. So I want to say the first and second rows and the first through third columns, I'm going to put 0L for integers. Now, if I look at the structure of XMAP, I'll see that I'll see it's still numeric here, but now the type and class should be different. Well, the class should still be matrix, but the type of is still double. That's interesting. Well, that's very interesting. Is dot integer. Let's try this out. It's not. Well, that's unexpected. I'm gonna have to think about that. I don't know why that is. Okay, let's go back. I tried to be clever using this trick. Let's go back and start it from scratch. So we'll go back and we'll create XMAT as a matrix of, this time for sure, integers. And we're going to say n row is equal to 2 and n call is equal to 3. So structure of XMAT. Okay, now it's an integer matrix. Huh, that's interesting. I really thought that that would have worked, but it didn't. So we're learning something. So I've got my integer matrix, and then I'm going to give row names and column names to this thing. So call names of x mat is going to be, as we said before, x, y, and z, x, y, z. And now we look at the structure of xmat. And again, we have column names. So we've got our dimension name attribute for an integer matrix. And then let's add our row names. Row names of xmat is going to be sample1 and sample2. Let's see if I can just copy this from above. Yeah, let's copy this. So now xmat. Okay, so here's this is the row for sample1, our row for sample2. And then let's see if I can highlight just this. Oh, no, it won't let me. Okay, here's my column for X, my column for Y, column for Z. And we can see that the type of xmat should be integer. Hey, it's an integer now. The class is still going to be matrix. Yep, the class is still matrix. And the structure shows all of the components. So the structure shows my 2-row and 3-column integer matrix, but it says that I have attributes known as the dim names, and I have a length 2 character vector for my row names, and I have a length 3 character vector for my column names. So is this atomic vector? Yes, it is. This is an integer vector. Okay. And I'm pretty sure if I do is.atomic, it'll show me that. Yes, it is atomic. It is an atomic vector. But it has extra information related to this atomic vector that allow us to kind of bend the rules a little bit and allow us to say, okay, well, I've got integer information in the matrix itself, but I need to be able to store more than integer information for the row names or for the column names. And this idea of an attribute allows me to do that. Okay. So attributes allow us to kind of bend the rules a little bit with integer information. And we can find the attributes of objects. So let me go back. Let me type attributes of xmat. And it tells me that there are actually 3 attributes here, which we don't see with the structure function. The structure function doesn't give us all of the attributes. It doesn't show us this dimension attribute. And this is something important for you all to learn. A matrix, so this is an objective class matrix, is just an atomic. So we see that this is true. It is an atomic vector with a dimension attribute. So that's really the only thing that a matrix is in R. It's an atomic vector that has a dimension attribute. Now, people will often ask me like, okay, well, what's the difference between like a matrix and a data frame or a matrix and a Tibble? And I'm going to say, okay, well, first of all, matrices in R are very, very, very simple. They must be atomic. They have to be atomic information. Whereas data frames and Tibbles do not. Data frames and Tibbles are non-atomic. And specifically, I said that for this class, we're going to be talking about something called a Tibble. So Tibbles are non-atomic information, but matrices are atomic information. Matrices are an atomic vector with a dimension attribute. And if we have dimensions, then we can have dimension names as another attribute. And so the first dimension name, which is the dimension of like the rows, is going to be this character vector. The second dimension name, so we see we have square bracket 2, is going to be this vector, another character vector for the columns. So this is how we can kind of bend the rules a little bit and add 2 different classes of information, and we can use an attribute to do that. So we can have attributes that are character information while the vector itself is integer, Or we could have attributes where the vector itself is logical while the attributes are integers, or all sorts of different combinations. As long as what's inside the vector is all atomic, i.e. all the same class, then the attribute that we kind of stick to the outside, that can be a little bit more flexible. Okay, so here's where we're going to pause this video. I am going to I'm going to come back and talk a little bit more about creating attributes. Actually, no, I'm just gonna finish this. I'm gonna finish this because I already talked about this a little bit. Um, so if we assign a dimension attribute to an atomic vector, then it will turn into a matrix. Okay, so again, this is just reiterating this idea that matrices are simply atomic vectors that have a dimension attribute attached to them. Okay, and we can create attributes. Attributes can have, like, we can create whatever attributes that we want. R will probably not know what to do with them unless you create another function to tell R what to do with that attribute. But you absolutely can just add whatever attributes you want at any point you want, and R will store it. It just R may not be able to do anything with it, but it'll be there for your sake if you're interested. So here's some exercises for you, and do these exercises. And I think there's another exercise here talking about adding, like, that attributes affect the class of the object. Okay, and we're going to pause there, and we're going to come back. We're going to pick back up next time with named subsetting. Okay, see you soon.